Eureka!
The story so far. Machines don't reduce the energy you need to move things, but they can reduce the force you need. They do this by increasing the distance through which you exert your force. The two simplest machines are the inclined plane and the lever. The principle of the lever states that the longer the arm of the lever to which force is applied, the less that force need be. And now, mechanical advantage and friction. Here are two scientists, Professor A and Professor B. They are both equally strong. And here is a very heavy book about science. We are now going to perform a scientific experiment. We are going to find out which of the two professors can lift the book with the lesser amount of force. First, Professor A. 24 newtons of force. Now, Professor B. Only, what? 6 newtons? Well, there's no doubt about it. Professor B is the winner. You're quite right. It's not fair. Professor B had an unfair advantage. He used a machine, a lever, to give himself a mechanical advantage, in fact. But just how much mechanical advantage did the lever give Professor B? It's easy to work out. Both professors lifted the book to a height of about 10 centimeters. Professor A lifted it straight up, so he had to pull against the full force of gravity, which was pulling the book down. But since Professor B's lever arm was 4 times as long as the arm the book was resting on, he only had to pull with 1/4 the amount of force, 6 newtons instead of 24. In other words, his input force was 6, and his output force was 24. And all you do to calculate the mechanical advantage of a machine is divide the output force by the input force. So Professor B's lever had a mechanical advantage of 4. You'd like us to repeat the experiment, Professor A? You think you can equal Professor B's feat